This is Mrs. Witt, and this video is going to be about generating equivalent equations. So let's first begin by let's recall what is an additive inverse. Well, the additive inverse is what gives us 0 when we add them together. So we might think of them as opposites. Like, let's say 2, I gotta get this here. All right, so 2, we can say, well, what is its opposite? Its opposite is -2. How do we prove that? Well, we know that an additive inverse, or its opposite, you add together to get 0. Okay, so let's see, how are we going to prove this? Well, how do I prove that 2 and -2 are opposites, or the additive inverse? Well, I'm going to add them together to see if I get 0. And that is an absolutely true statement. 2 plus -2 equals 0. It is its additive inverse. So our definition of an additive inverse or opposites is that we add them together to get 0. Okay, with that in mind, I want you to take a few minutes and fill out this chart. All right, if you're on Edpuzzle, I will have prompted you to fill out the chart, asking some questions. And I'm going to go ahead and just show you this, what it should look like when it's all finished, so that we can check our work. All right, so we see that the opposite of 3 is -3. The opposite of -7 is +7. The opposite of -1/2 is +1/2. And the opposite of x would be -x. All right, so let's write the opposite of the following expression. So x plus 3. Well, how am I going to write the opposite of a whole expression? I know what it's like if I just had one term, but how do I do? Well, the opposite of x plus 3, I would be able to add something to that, and it would give me 0, right? So let's think about this. What is the opposite of the first term? What is the opposite of x? Well, the opposite of x would be -x. And what would be the opposite of a +3? It would just be a -3. So what expression is the opposite of x plus 3? Well, it would be a -x plus a -3. Or I might want to write that as -x minus 3. That means the same thing, right? Because adding a negative is the same as minus. So what is the opposite of x plus 3? The opposite would be -x minus 3. Because when I add those two things together, they give me 0. Right? So do you believe me? Do we need to check that? Let's take a minute and look at that. Okay? So if I have x plus 3, and I combine with that -x and a minus 3, right? -3. Or I could say, let's see, what's a good way to write that? Let's look at that. Let's write that as plus my -3. Does that give me 0? Well, let's combine our like terms. I've got a positive x and a -x. Those go to 0. And I've got a +3 and a -3. Those go to 0. The only thing remaining is 0. So yes, that is indeed true. All right, let's see. Would this relationship also be true for this expression? Okay, so I want to know if I can find something. Oh my goodness, if I find something, it would be 3x minus 7. That's my first one. And I want to be able to add its opposite and know that that would give me 0. Okay, so let's do the same thing. What is the opposite of 3x? Well, -3x. What is the opposite of negative 7? Well, that's a positive 7. So I know that the expression I need to add to that is negative 3x plus 7. And that would give me 0. So the opposite of my 3x minus 7 is negative 3x plus 7. And can we check that to see if it's true? Absolutely, we can check that to see if it's true. Let's add them together. I've got 3x minus 7, and I'm going to add to that, negative 3x and a positive 7. And I want to know if it ends up as, does it end up as 0? Well, let's see. Let's see, I've got my 3x and negative 3x, those cancel each other out or they add to 0. And then I've got a negative 7 and a positive 7. Those also add to 0. The only thing left there, well, there's nothing left there, just 0. Number 0 is a number. So yes, those are opposites. So what rule can we generalize for the opposite of a sum? So we're thinking about sums, all right? So we want to think about, let's see, the opposite of a sum. Well, let's go back and look. We wanted to find out what was the opposite of this sum. And what did we do? What did we take? Well, we took the sum, we added together some stuff, right? So let's think of it. The opposite of a sum is the sum of its opposites. All right, so take a minute, pause if you need to, and try to sink that in. Okay, so let's say the opposite of a sum. Do we need to see an example of that? Do we need to kind of unpack that a little bit? So the opposite of a sum. So let's think of a sum. Let's see, x plus 3. That's a sum, right? It's adding something together. That's what sum means. And we want to know what is its opposite. Well, that means something that we can add to it that will give us 0. And we want to see if it is, well, what did we do? What is the opposite of x? What is the opposite of x? The opposite of x is negative x. The opposite of 3 is minus 3. Okay. And remember, we could write that. Let's write that a little bit differently. If we added it together, let's see, plus a negative 3, right? That's messy. Let me make that a little bit cleaner. So what is it? Let's see, the opposite of x is negative x, and the opposite of 3 is negative 3. Okay, so is this the sum of its opposites? That's exactly what that is. The opposite of x is negative x. The opposite of 3 is negative 3. If we add them together, that's the sum of its opposites, right? So this part, the sum of its opposites, that's this part right here, okay? And that gave us the opposite, right, of this. And we know that it's its opposite because it added to 0, okay? So what rule is it? The opposite of a sum is the sum of its opposites. Let that sink in for just a second. All right, so now let's try it with this example. Let's subtract 40 plus 9 and subtract from that the expression 30 plus 2. Okay, well, we can do that more than one way, but let's look at it. Let's first do it, let's use the order of operations, the way we've always done it. So I've got 40 plus 9 minus 30 plus 2. Well, the order of operations says that I use my I do my grouping symbols first, right? So I would do 40 plus 9 is 49. And then what is 30 plus 2? Well, that's 32. So what's 49 minus 32? Let's see, 49 minus 32. That's just 17. Okay. And if I think about that rule, I know, let's see, 40 plus 9, and then minus 30 plus 2. Well, basically when I'm talking about using that rule, I'm saying that I can add the opposite, right? So let's see, what's 40 plus 9? That's still, oh my goodness, sorry about that. What's 40 plus 9? Well, that's still 49. But I can add the opposite, right? So instead of minusing 30 and plus 2, I could add the opposite. So I could add negative 30, and I could add, what's the opposite of positive 2? Negative 2. Okay, so now what is 49 minus 30? Let's take this first part. Well, that's 19. And then, so I've got 19 plus a negative 2. What is 19 plus negative 2? Well, that's 17. All right, so do both methods yield an equivalent answer? Is 17, I got 17 here, is that equivalent to 17 here? Well, as a matter of fact, yes. But I want you to think about it. What method would you choose to use in this situation? And you can answer however you'd like. You could say that you'd like to use the order of operations because whatever your reasons might be, or that you like to use that rule of just adding the opposite. You could choose that. So think about that and answer that. All right, now let's look at this example. Well, this example is a little bit different, right? Because if I were to use the order of operations, I would look first in this group, and then I would subtract something from this group. But I can't combine anything in the first group, right? Because there's no like terms, and I can't combine anything in the other one either because there's no like terms there. So the only way that I'm going to be able to like combine any of these things together is by looking at using that rule, right? So the rule is that I can subtract by adding the opposite, right? That's a rule we know. So let's say if I start off with 3x and plus 5y and minus 4, and I want to add the opposite of this expression right here. Okay, so I'm going to add, well, what is the opposite of 4x? Negative 4x. And I want to add the opposite of positive 11. So I'm going to add a negative 11. All right, let's look at combining some like terms now here. Let's see, I've got my 3x and negative 4x. Well, if I have a positive 3x's, so I could look at that like if I have a positive 3x's and I take away 4x's, how many x's do I have left? Well, I just have a negative 1x or a negative x. And then let me look at my y's. So if I have positive 5y's there, I don't see any other y's around, so I'm going to keep just that positive 5y's. Okay, and finally let's look at my constants. I have a negative 4 and a negative 11. If I combine those together, I'm going to have a negative 15. Okay, so I simplified using, so let's see, I subtracted by adding the opposite, and I knew that the opposite, I could do that. Let's see, I was able to combine my like terms, and I came up with this, saying that this is that simplified expression. That's when I subtract, that's what I get. And how do I know if that is accurate? Well, I can check my answer by substituting in. Let's substitute in, I'm just going to pick these arbitrary numbers, that x equals 2 and y equals 6. So I want to plug that into this one, and I want to plug that into this one to see if they give me the same thing. Okay, so if I plug it into the first one, I've got 3 times 2 plus 5 times 6 minus 4. And then I'm going to subtract from that, let's see, minus 4 times 2 plus 11. Okay, so let's see this. 3 times 2 is 6, plus 5 times 6 is 30, minus 4. And I'm going to subtract from that. Well, what is 4 times 2 is 8, plus 11. So let's just keep going with this. What's 6? 6 plus 30 is, let's see, 36 minus 4. And over here I'm going to have minus, what is 8 plus 11? 19. Okay. 36 minus 4 is 32 minus 19. 32 minus 19 is 13. Okay. So we got that this is 13 when we plug that in. Let's see if we get the same thing down here. So I've got negative 1 times x, which is just basically negative 2 plus 5 times 6 minus 15. Okay, so let's see. I have to do 5 times 6 first. So I've got negative 2 plus 30, and I've still got minus 15. Okay, negative 2 plus 30 is 28. And then I've got minus 15, or plus a negative 15, however you want to look at it. And there I get 13. So let's look at this. I got 13. So I got 13 with the original, and I got 13 after I subtracted it with this expression here. So I know that I did do that correctly because it gave me an equivalent statement. All right, now let's take that beyond adding and think about if we can extend this on to multiplication. So first let's recall, well, we already did the additive inverse. Well, if we're going to think about multiplying, let's see, what is the multiplicative inverse? Well, the multiplicative inverse, it doesn't give you 0. It's when you multiply the terms together, it will yield 1. Okay, so like if I said, what is the multiplicative inverse of 2? And I think it's 1/2. Well, how would I check that? If I multiplied them together, would they give me 1? Is 1/2 of 2 1? It is. So these two are multiplicative inverse. And we also talked about that as being the reciprocal. Okay, we know, if we're thinking about the reciprocal here, we know that 2 is the same thing as 2 over 1. And the reciprocal is that flip, right? 1 over 2. So you multiply straight across on the top, you get 2. Straight across on the bottom, you get 2. And that does equal 1. Okay, so that is your multiplicative inverse is your reciprocal. When you multiply them together, you get 1. So I want you to take a minute and let's really engage that concept. And I want you to take the expression in the first column and consider what its opposite is and show me the proof of that. And you show me the proof by saying, well, when I multiply the expression and its opposite, it should give me 1. All right, take a moment to do that. Okay, you should have had a moment to do that, and we'll work through it on Edpuzzle, depending where you're watching this video. And here, I'll go ahead and reveal my copy of this so that you can check your work. Okay, so that's what that chart should look like. And again, let's just answer that question. How do we know that two numbers are multiplicative inverses? Well, we know they're multiplicative inverses when they multiply to 1. And what can we say about the signs of multiplicative inverses? Multiplicative inverses or reciprocals, and why? I want you to take a moment and think about that. What can we say about the sign of a term and its inverse, or its opposite, its reciprocal. All right, so to think about that, what happens when I take a positive and I multiply that times a positive? What do I get? I get a positive. What if I take a negative and I multiply with that a negative? What do I get? I get a positive. And if we know that this multiplies to 1, or positive 1, that's always going to be a positive 1, I know that both my term and its reciprocal have to be the same, right? They both have to be positive or they both have to be negative so that I can end up with a positive term. Because if I were to take a positive number and multiply it with a negative, because see, when we're doing additive inverses, we take the positive and the negative of something, right? And we add them together and that gets us 0. But here, this is something different. We want it to end in a positive 1. So I can't take a positive of something and a negative of something else and get a positive 1, because that will always give me something negative. Remember how we reviewed that last semester, how that negative sign flips it, okay? So what can we say about the signs of reciprocals? Well, we know that they have to have the same sign as the original term, right? And why is that? Because we want it to always, we're looking for positive 1 as the answer. So in order to do that, the signs both have to be positive or they both have to be negative. So just a quick recap, let's summarize this. We can use the commutative and associative properties to reorder or regroup for any addition, right? And multiplication, that's something we've talked about before. And that subtraction and division, they're not commutative or associative. But with the additive inverse, subtraction can be rewritten as adding the opposite so that we can regroup and we can reorder. And the multiplicative inverse, division, can be written as multiplying the reciprocal. So that, again, we can go ahead and do reordering and regrouping. We can use that associative or commutative properties because those can be used on multiplication and division, but they can't be multiplication and addition, but they can't be used on division or subtraction. So we want to rewrite those things so that we can form equivalent statements that we can manipulate more easily.